Hello engineers, welcome back. In this video, we're going to practice the concept of stacks using a lead code question. I hope you're ready. Let's get started. So this is the question we're going to look at today. It's called valid parenthesis. It's a commonly asked interview question. Let's try to understand the question and then we'll see how we can use stacks to solve this, right? So given a string S containing just the characters these are the brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open bracket must be closed in the correct order. Every closed bracket has a corresponding open bracket. Okay, let's try to understand this with an example. Let's say we have these, right? Let's say our input is like this. Now this string satisfies all these properties. Open brackets must be closed by same type of brackets. So when I'm having an open bracket, it must be closed with the same type of bracket. So if this is the open bracket, it must be closed with this bracket, right? Secondly, open bracket must be closed in the correct order, which means if this is the open bracket, if this is open bracket, it needs to be closed with the closed bracket. It cannot be like there is a closed bracket first and then there is the open bracket. This is invalid. This is valid, right? The order needs to be maintained. And then every closed bracket has a corresponding open bracket of the same type, which means in the entire string, if there is one open bracket for this, there must be a closing bracket. Similarly for this, there is a closing bracket, opening bracket. Similarly for this, flower brackets as well, there is an opening and there is a closing. And if there is anything left open, then it must be closed. If there is no closing bracket available for this guy, then this is an invalid string. Okay, so every bracket which is open must be closed and in the correct order, and every bracket must be a pair. There must be an opening and a closing, right? Consider this example. There is an opening bracket and there is a closing bracket, but they are not related to each other. So this guy will require this closing bracket. This square bracket requires this opening bracket, and this opening bracket should be before the closing bracket. So all these conditions should be maintained. Okay, so that is the question. So let's see how we can approach this. As you know, we have this condition that open brackets must be closed in the correct order, which means we have to maintain the order somewhere. So as we iterate through this list, we will check each character and we will have to maintain an order for these characters. So for this, we can use the concept of stacks. So how can we use this? So let's say this is our stack. Whenever I'm seeing the opening brackets, I'll push the opening brackets to the stack. So as I'm iterating through this list, my correct pointer is here. Let's say this is my pointer and it is here. Okay, so when I'm here, I will check, is this the opening bracket? Yes, then I will push it to the stack. Okay, my stack has the opening bracket now. And as I iterate through this list, whenever I'm encountering a closing bracket, now my pointer is here and this is a closing bracket, right? Encountering a closing bracket, which means that what am I closing? I am closing the previously opened bracket, right? The previously opened bracket must be closed. I cannot close somebody else's bracket. I cannot close it like this. This is invalid, right? Because whatever is opened must be closed, right? This is open, this is open. Now it can only be closed like this. This is valid. I cannot close a square bracket with this small bracket. I cannot close a flower bracket with the small bracket like this. This is invalid. So the order needs to be maintained. So whenever I'm opening, let's say I've opened the small bracket and then I have opened the square bracket. So the closing bracket must be square bracket first. Only after that can there be a closing bracket of this small type. Right? So the order needs to be maintained. So I can use this logic that whenever I'm encountering a closing bracket, I will check on the stack. I will check on the stack using stack.top. Give me the topmost element. Now the topmost element is this small bracket, right? And my current element is this closing bracket. So I'm comparing, is this closing bracket closing the correct type of bracket? So my element is this guy, small bracket. So is this small bracket closing the correct type of opening bracket? If it is, then we are still in a valid state. I can simply pop this. I will pop this. Okay, now there is nothing in the stack. Now my pointer is here. I've encountered an open bracket again, so I will add it to my stack and I will move forward. Now I have encountered another closing bracket. Now this time again I am checking, am I closing the same type of opening bracket? So my s top will now give me top will now give me the square bracket, and my current element is the closing square bracket, right? So these two are a pair, so I can safely remove it. So I will pop this. We are still in a valid state. Next, now my pointer is here. I found an opening bracket, so I will add it to the stack. I will move forward. Now I have encountered a closing bracket, so my s.top will give me the opening flower bracket, and my current element is a closing flower bracket. So these two are a pair. So I'm happy to consider them a pair, and this is a valid state, so I will pop it. Okay, and we have reached the end of the string. So at the end of the string, if there is nothing in the stack, then my entire string is valid. Okay, but if there is anything left in the stack, which means there was somebody who got opened but they did not get closed, which means it is an invalid string, right? Consider this case. So we have iterated through all this. This is a pair, this is a pair, this is a pair. Now I have encountered a new flower bracket. I will add it to the stack, but I've reached the end of the string, but my stack is not empty, which means there is an open guy left behind, which means this is an invalid case. So in this case I will return true, in this case I will return false, right? Consider this example as well. So there are 4 elements. So my stack is like this. So first opening bracket, I have added this flower bracket. Then I have added another small bracket. Now next time I got a flower closing bracket. So from the flower closing bracket, I will ask, what is s.top? S.top will give me a small bracket. This is not a, my current element is this, right? Current element is this guy, closing flower bracket. But my top is opening small bracket, which means this is not a pair. So I will exit here itself. I found a case where the opening and closing are not matching. This is not a valid case. I will return false from here. Okay. Let's consider this example. So I'm iterating through this list. First opening bracket, I've added this, then another opening bracket, this. Now I've encountered a closing bracket. I'm here now. I've encountered a closing bracket. So I'm asking what is at the top? At the top is this guy. And what is the current element? Current element is closing square bracket. So this is a pair, which means I can safely pop it, no problem. Okay, and I will move on. And what is the next element? Next element is this guy, which is a closing small bracket. So my s dot top will give me opening small bracket, and my current element is closing small bracket. So this is a pair, which means I can safely pop it. So I have popped it. I have reached the end of my string and the stack is empty, so I will return true. Okay. So that's how we're going to use stack to check if the string is valid or not. Let's code this on Leet code. So let's take a stack. Let's call it character stack. You can call it anything, and we need to give a data type. So every element inside the stack will be a character. Okay. Now let's iterate over the string. Let's see. What did we say? Whenever we are coming across an opening bracket, we will add it to the stack, right? So if s of I is equal to the opening brackets, okay, these are my opening bracket. Whenever we are encountering an opening bracket, we will add it to the stack, right? Character stack dot push. Okay. And whenever we are encountering a closing bracket, we will pop it. So this is closing bracket. Pop. Okay. And at the end of the whole thing, we are checking if character dot stack dot size, if it is 0, then return true, which means all elements have been pushed and popped and there is nobody remaining. Else return false. Okay, so this will solve some cases. Now we will take care of edge cases. Okay, this is I plus plus. Okay, two cases are solved. Now we will look at this case. There is an opening bracket and there is a closing bracket, but they are not a pair. So we need to check for the pair case. So whenever we are encountering a closing bracket, we need to check, is it corresponding to the pair that got inserted before this, which means whatever is in the top. So let's say my s of I equal to the small bracket, right? This is the closing bracket. Then what am I expecting to be at the top of the stack? My top of the stack should have the opening small bracket, right? This one. This should be there. If it is not there, then it is an invalid string, right? So we will check if character stack dot top. This will give me the topmost element. If it is not equal to this guy, the opening small bracket, then return false. They need to be a pair. If it is not a pair, then I'm not interested in the string. And we need to do this check for two other types of brackets. If this is a closing flower bracket, then I should expect an opening flower bracket at the top. if it is a closing square bracket, I should expect opening square bracket at the top. Otherwise, I'm not interested. Okay, let's run it. Okay, so this case is taken care of. Next, there is one more case, a small edge case. We'll consider it now. It is this guy. There are no opening brackets, but there is only one closing bracket. So this is straightforward and invalid string, right? We need an opening bracket to evaluate a closing bracket. So which means whenever we are coming across a closing bracket, there should be something in the stack to check it against, right? When there is nothing, we are getting this type of error, right? We are trying to access a memory element which does not exist. The stack is empty, but we are trying to see what is on the top of the stack, right? Which is not valid. So we can do a small check here. So whenever we are encountering a closing bracket, we will check if there is anything in the stack. If character dot stack dot size, if it is 0, then no need to check anything. It is straightforward and invalid string and return false. Okay, so our solution is accepted. So the time complexity is obviously O of n because we are iterating over one element of the string, and space complexity is also O of n because we have used additional stack space. Okay, so that is our solution. So that is it for this video, guys. If you found this helpful, please do leave a like. Do comment if you have any questions or suggestions. Don't forget to subscribe to the channel. Don't forget to bookmark the playlist. Don't forget to share it with your friends. Thank you so much for watching, guys. I will see you in the next one. Cheers.